Okay, it's one of our scalar product questions. We've got two lines with equations of this vector form and the second equation of that vector form. Given the lines meet at point C, we've got to find the coordinates of point C. So for section A, these two R vectors must be equal. So we're going to put them into a single vector form. So we've got 2 plus lambda, 3 plus 2 lambda, minus 4 plus a lambda, and that must equal our mu values, which is going to be 0 plus 5 mu, and 9 on its own, and minus 3 plus 2 mu. Now, normally in this question you would try and solve simultaneous equations to eliminate either mu or lambda. But in this one, they've been particularly nice and given us a value. We can actually solve the equation. So we're going to check and say 3 plus 2 lambda is equal to 9. So lambda is equal to 3. So we subtract the 3 and then divide by 2. We should also check and show that this works for the others. So let's just do a check on the top. 2 plus 2 plus lambda, which is 3, equals 5 mu. So that's 2 plus 3 equals 5 mu, tells me mu equals 1. And check with the last equation that the 3 and the mu both work. And minus 4 plus 3 equals minus 3 plus 2 times 1. That's negative 1, and negative 1 is correct. So this is an intersect. And to find the point C, we substitute in either in the mu or the lambda. So let's put in the lambda in the top. So it's 2 plus 3, 3 plus 2 times 3, minus 4 plus 3. So C is at the position 5, 9, and minus 1. Okay. Point A is a point of L1 where lambda equals 0. Well, that immediately says it's at 2, 3, minus 4. And point B is where mu equals minus 1. Find the angle of ACB. Give your answer to 2 places. So first of all, let's find the position A. A is where we've got 0 in, so that is just straight into this value here. 2, 3, minus 4. Two, 3, and minus 4. And B is where mu equals minus 1, which is 0, 9, minus 3, plus minus 5, 0, minus 2. 0, 9, minus 3, minus 5, 0, and 2. That can add on minus from the mu. It tells me B is at the point minus 5, 9, minus 5. Find the size of the angle ACB. So we need the vector AC. And if you remember, we go back along OA. So we have negative A, minus 2, minus 3, and 4. And we go forwards along OC. OC is 5, 9, minus 1. Gives me the final vector along that first edge of 3, 6, and 3. and the vector BC or CB, which is going to be minus OC plus OB. So OC minus 5 minus 9 plus 1 plus B, which is minus 5, 9 and minus 5. Gives me minus 10, 0, minus 6. And then calculate the angle. Well, calculating the angle is the dot product of two vectors equals the magnitude of A times the magnitude of B times the cos of the angle between them. Okay, so let's do the modulus of A, which is the square root of 3 squared plus 6 squared plus 3 squared. That's 9, 18, that's 54. Modulus of B is going to be the square root of minus 100 plus 0 squared plus minus 6 squared, which is going to be the square root of 164. So we now get a rearrangement of this, saying let's just do A dot B as well. Remember, this is the I part times the I part. So it's 3 times minus 10 plus 6 times 0 plus 3 times minus 6. Actually, maybe you should have done this one first, just in case the angle worked out as being a 0. If this came out as 0, you know they're perpendicular. So we've got minus 18 minus 48. So cos of my angle between them is this minus 48 divided by the square root of 54, square root of 164. Minus 48 divided by the square root of 2.64 would be minus 0.51. And that tells me the alpha, which is shift cos of that number, is 160.67. 20.67 degrees. I think they asked for 2 decimal places. Yes, they did. Just noticed here, we've got now a minus 4. So that should be minus 4 squared is 16, so that's 116. That also changes the product of this last part, minus 4. So that's minus 12 plus 30 is minus 42. So it's minus 42 over square root of 116. Minus 0.475. Inverse cos of that gives me 119.7. Just found an error in the calculation, so I typed something wrong into the calculator. And shift cos, that answer gives me 100. Alpha is theta is 122.05 degrees. Checking the wording, find the sort of angle. It's 2 degrees ACB. Now we found the obtuse angle. You've got A, C, B, and we found the angle going like that. Change. The alternate angle between the acute angle would be 180 minus this, which is 57.95. And now the final part, and this is why we needed the acute angle really, is to find the area of the triangle. We've got an A, we've got a B. Area of the triangle is the sine, using the sine function. And we actually effectively project A into a perpendicular height. So the area of that is magnitude of the first side, which is still here, the root 54, times the root of 116, times the sine of the 57.95 degrees, to give me an area that gives me 33.54 square units.